about converting an image to grayscale by applying some blur, by creating an edge cascade, by dilating the image, by eroding that dilated image, by resizing an image, and trying to crop an image using array slicing. In the next video, we're going to be talking about image transformations in OpenCV. That's translation, rotation, resizing, flipping, and cropping. So if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to this Python and OpenCV course. In this section, we're going to cover basic image transformations. Now, these are common techniques that you'll likely apply to images, including translation, rotation, resizing, flipping, and cropping. So let's start off with translation. Translation is basically shifting an image along the X and Y axis. So using translation, you can shift an image up, down, left, right, or with any combination of the above. So to translate an image, we can create a translating function. We're going to call this def translate. And this translation function will take an image to translate and take an X and Y. X and Y basically stand for the number of pixels you want to shift along the X-axis and the Y-axis respectively. So to translate an image, we need to create a translation matrix. So we're going to call this transmet is equal to np.float32, and this will take in a list with two lists inside of it. In the first list, we're going to say 1, 0, x and 0, 1, y. And since we're using NumPy, we can import NumPy as np. And once we've created our translation matrix, we can essentially get the dimensions of the image, saying dimensions, which is a tuple of image.shape of 1, which is the width, and image.shape of 0, which is the height. And we can return cv.warp affine. This will take in the image matrix, so transmet, and it will take in the dimensions. And with that done, we can essentially translate our image. Now, before we do that, I do want to mention that if you have negative values for X, you are essentially translating the image to the left. Negative Y values imply shifting it up. Positive X values imply shifting it to the right. And as you guessed, positive Y values shifted down. So let's create our first translated image. By setting this equal to translate, we're going to pass in the image, and we're going to shift the image right by 100 pixels and down by 100 pixels. So let's do a cv.imshow translated and translate. Save that and run Python transformations.py. And this is your translated image. It was shifted down by 100 pixels and shifted to the right by 100 pixels. So let's change that. Let's shift the image left by 100 pixels and down by 100 pixels. So we pass in negative values for X. And it moved to the left. Feel free to play around with these values as you see fit. Just know that negative X shifts it to the left, negative Y shifts it up, X shifts it to the right, and positive Y values shift it down. Moving on, let's talk about rotation. Rotation is exactly what it sounds like, rotating an image by some angle. OpenCV allows you to specify any point, any rotation point that you like to rotate the image around. Usually it's the center, but with OpenCV you can specify any arbitrary point. It could be any corner, it could be 10 pixels to the right, 40 pixels down, and you can shift the image around that point. So to rotate the image, we can create a rotating function. It's called devRotate. This will take an image angle to rotate around and a rotation point, which we're going to set as none. So we're going to grab the height and the width of the image by by setting this equal to ing.shape of the first two values. And basically, if the rotation point is none, we are going to assume that we want to rotate around the center. So we're going to say rot point is equal to width divided by 2 and height divided by 2. And we can essentially create the rotation matrix like we did with the translation matrix by setting this equal to rot met is equal to cv.get rotation matrix 2D. We're going to pass in the center, the rotation point, an angle to rotate around, which is angle, and a scale value. Now we're not interested in scaling the image when we rotate it, so we can set this to 1.0. Finally, we can set a dimensions variable equal to the width and then the height. And we can return the rotated image, which is cv.warp affine image rot met, the destination size, which is dimensions, and that's it. That's all we need for this function. So we can create a rotated image by setting this equal to rotate, and we can rotate the original image by 45 degrees. So let's display this image, call this rotated, and pass in rotated. Save that and run. And this is your rotated image. As you can see, it was rotated counterclockwise by 45 degrees. If somehow you wanted to rotate this image clockwise, just specify negative values for this angle, and it will rotate the image around. Rotated clockwise. Now, you can also rotate a rotated image. That is, take this image and rotate it by 45 degrees further. So let's call this rotated